Hi everyone, in this video we are going to review the atomic structure. And so in order to do that, we need to make a chart to basically go through and dissect the three main particles. So we have a proton, we have a neutron, and we have an electron. So there's four different categories that we absolutely have to master in order to talk about an atom properly. First one, let's identify the particle. After we identify the particle, it's very important to identify the charge. After we talk about the charge, we need to talk about the relative mass. So this is a relative mass. I want to say in terms of protons and neutrons, what's the relative mass? That's not their actual mass if you weigh it out in a balance. If you weighed it out in a balance, we could also come up with a term in terms of kilograms, but it's very, very tiny, so this relative mass is actually a super important category. So let's go through these one by one. Starting off with the proton. So a proton has a charge of positive 1. It also has a relative mass of 1. In real life though, if we were to grab one proton and somehow find a way to put it on a balance and walk away and measure it, what we would see is that it has a mass of 1.67 times 10 to the negative 27th kilograms. I mean, that is tiny. That is so incredibly small, I can't even put an analogy to explain like how small that is. I mean, it's incredibly small. Negative 27, 10 to the negative 27, that's incredibly small. So let's talk about a neutron. A neutron has a charge of 0, okay? So we say it's neutral, there is no charge. It also has a relative mass of 1, and that is simply because it has the exact same mass as a proton. So we say it's 1.67 times 10 to the negative 27th kilograms. Now, in comparison of these, a proton and a neutron are considered giant when we are ranking them against an electron. So an electron, hopefully we know this, has a charge of negative 1. This is our negatively charged particle. Our relative mass to a proton and a neutron is 0. So when we're talking about the three particles, we say that an electron has a mass of 0. Obviously that's not the case. It definitely has a mass, but we'll see that in just a second that its mass is actually 9.11 times 10 to the negative 31st kilograms. So relative to a proton and a neutron, it does have a mass of 0. It's just non-existent in the grand scheme of things. So here are our three main particles, and what we need to do now is understand where they exist in terms of an atom. So we said our nucleus is our core. So this is our nucleus. Nucleus is the core. It is your center of your atom. And inside your nucleus is where your protons exist and where your neutrons exist. On the outside, like flitting around the outside, that's where your electrons are. So they could be here, they could be here, they could be here, but they are never, ever, ever going to be in here. You're never going to have electrons there. So we absolutely have to get that straight. So I always use my body to talk about an atomic structure. So inside my belly, inside my core here, that's where my protons and neutrons exist. My fingers, maybe my elbows, my arms, these are my electrons. I can move them all around, but no matter what I do, unless I had like a knife or something crazy, I cannot get my electrons inside of my nucleus. So try to keep that straight in your head as we move forward with this unit. So after we've introduced the particle terminology, I want to introduce another term, which is called the atomic number. So for an atomic number, we have quite a very, very specific definition. So I want to make sure we get this absolutely perfect. So an atomic number is really just your number of protons. Okay, protons, only protons. We're never talking about electrons or neutrons for this. An atomic number is your number of protons in the nucleus of an atom. Okay, but I'm going to add something onto this. It defines your element. And another way of saying that is it gives it an identity. So using your atomic number, you can actually determine which element you're talking about based on the protons. So let's check in here. I want to ask you a quick question. Okay. What particle, or maybe which particle, is the most important when discussing the atomic number? Did we get an answer? Hopefully you said the proton. The proton is the only particle that actually matters when we're talking about the atomic number. The electrons are not going to have anything to do with this. The neutrons talk about something entirely different. The atomic number is entirely based on the number of protons inside the nucleus. Now, where do we find this atomic number? Luckily, we have this beautiful chart, also known as the periodic table, that has all of this information for us. So we've got our helium over here, big long P block, the D block, and then we can come all the way up here for the S block, and then we've got hydrogen. So what I want to do right now is just identify these two elements right here, the ones at the top. So here we have helium, and in this one we have hydrogen. So for the atomic number, normally what we see is we pull out one of these little elements, and we have this giant box, and what it will have is three main pieces of information. So it would have hydrogen right here, it would have the number 1 above it, and then it would have something tiny below it, like 1.008. So the 1 is the thing that I care about right now. That is called your atomic number. So your atomic number is just what's telling you how many protons you have inside the nucleus. So for hydrogen, it has an atomic number of 1, and that's because it has 1 proton inside the nucleus. Now, if we were to go to helium, helium's box would look just slightly different. It would have the symbol in the center, so helium. It would have a 2 right here, and then it would have something like 4.002, something like that. That's not perfectly accurate. But this 2 right there is your atomic number, and it's telling you that this specific element has 2 protons in the center, and by definition, that means that this element has to be helium. You are never, ever, ever going to find a different element with 2 protons in it aside from helium. By definition, if you have 2, it means you're helium. So now, hopefully that makes sense, so I'm going to push you. How many protons does carbon have? So you might have to get a periodic table for it. If you don't have one, just Google one. Go. All right, did we get an answer? If you did not, or you had any trouble with this, let's walk through it together. So the first thing you had to do was figure out what element carbon actually is, or what symbol it is. And so hopefully by now we've kind of started to get a feel for certain elements, but carbon is just big C. And so it's right here. And so all you had to do was look in this tiny little box and determine what that number is right there, the atomic number. And so carbon has an atomic number of 6, and so carbon only has 6 protons. It never has 7, it never has 5, it only has 6. So now we're going to try it from the other side. Which element has 46 protons? I'll give you a hint. It's my favorite element. Go. Did we get an answer? Hopefully we did. And so if you didn't, just we'll walk through this together. All you had to do was look for the number 46 on the periodic table. And so you'd go to your periodic table here, find the number 46, and then say, oh my good gravy, that means we definitely have palladium. Palladium is definitely my favorite element. It is my go-to. It's my favorite. I've worked with it through undergrad, through graduate school, and I still am obsessed with it. There's something about palladium that just makes me really happy. But regardless, all you had to do was go to your periodic table, find the number 46, and then just tell me what element is listed under that. And so now what you should be able to do from here on out is define what an atomic number is, and then tell me how is that related to protons, and how does that help us decide the identity of an element. So those are 3 questions you should be able to answer.